Hello everyone, today let's solve the problem number 70, climbing stairs. So what the question states here, we are climbing to the top of the staircase with n steps. So we are climbing the top of the staircase with n steps, right? So here we have been given n basically. So we are climbing to the top of the staircase with n steps. At each step we can either climb one step or two steps at a time. Maximum steps at a time we can climb was 2. Just remember this one. We can either go with one step at a time or two steps at a time. The maximum steps we can climb at a time as 2. Just remember this one. This is very important. That's what they have mentioned in the question. At each step we can either climb one step or two steps, right? So we need to count how many distinct ways we can reach the top. We need to count how many distinct ways we need to reach the top. To reach the top, how many distinct ways are there to reach the top? That's what we need to count here, right? Simple. So let's come to the first example here. Just give me a second. Yeah, here you can clearly see we have been given n2, n equals 2, right? So here in this case, if we climb one step at a time, it will be 1 plus 1, right? So then it will be 2. So we can climb the second step by one. If we climb one step at a time, then we will reach to 1 plus 1, right? So then we will reach to by considering two steps, 1 plus 1. So path is 1 comma 1 for this one, right? So then let's move on with the second way. Means we can directly climb the second step, 1 2. That also they have clearly mentioned in the question. We can either climb one step at a time or we can climb two steps at a time, right? So here 2, this is one path, right? 2 is one path. So these are the two distinct ways to climb the top. Basically n equals 2 they have given. These are the two ways to climb the top here in this case. Nothing but in this case we need to return 2. So path is 1 comma 1 and 2, and we have two distinct ways, right? So let's come to the second example here. In this case n equals 3 we have. So either we can climb here one step at a time. If we climb, this will be 1 plus 1 plus 1, right? Which is equivalent to the 3. So here the path is 1 comma 1 comma 1, right? So the step either we can climb here in this case one step, and then we can just hop into two steps. Then also we can reach the top. This will be 3, right? So this will be 1 comma 2. The path is 1 comma 2, and the third one is we can first itself we can hop into the second this one second step or the second step. Then we can climb one step, right? Means two steps plus one step. This also give us 3. Means by this way also we can reach the top. Nothing but in this case n equals 3 they have given. We can reach 3 in this way as well, right? So the path is basically 2 comma 1 for this, right? So these we have 3 ways: 1 plus 1 plus 1, 1 step plus 2 step, here 2 step plus 1 step. These are the 3 ways. So in this case we have to return output as 3. So that's what they have given here. In this case we return 2. In this way we can in this for this one example 2 we have to return 3, and for the example 1 we have to return 2. I hope the question is completely clear. What we need to do is completely clear as well, right? So now let's discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially let's discuss the approach first. So here the first thing that we need to keep in mind here is we will be going with the dynamic programming, DP, right? So or the you can just call this one as bottom up DP, right? So we'll be going with the bottom up dynamic programming. So first thing I have considered the same first example that they have given in the question, so that it will be easier to understand the approach. So here n equals 2 we have. So output we need to get here is 2. So what are the two different ways? We have already discussed this one. Either you can climb one step at a time from 0. This will be 1 plus 1, right? So here, sorry, this one will climb from 0 to 1 and then 1 to 2, right? This is 1 plus 1, which will lead to 2. Or we can just directly hop from 0 to 2. We can climb 2 steps at a time as well, right? They have mentioned in the question. Either we can climb one step at a time or 2 steps at a time. So 2. This is also this is the other way, right? 1 plus 1 or 2, 1 step at a time or 2 steps at a time. So the total number of distinct ways is 2 here in this case. So we need to return the output as 2. This is fine. Let's move on with the next edge case. Sorry. Now let's discuss the step-by-step execution, right? So first we are on the step 0 initially, right? So we can claim either 1 plus 1 steps, that is path 1 comma 1. We have already discussed this one. 2 equals 2 steps, path 2 here in this case. Path is 1 comma 1, right? So we went to 1, then next this one 1 plus 1. So path will be 1 comma 1, 2. This will be, by this way also we can reach the top, nothing but 2. The path is 2, just 2 right here. These are the paths we have considered: path 2, path 1 comma 1. 1 plus 1 equals to 2, right? So these are the two distinct ways. So final output here is total distinct ways is nothing but 2 in this case, right? So that's what we need to return. So the output that we got is 2, and the output that they have given for the example 1 is also 2 in the question. So the approach works absolutely correct in this case. Now as we are completely familiar with the approach, let's discuss the edge cases one by one. So first one is for when n equals 1. We have n equals 1. So there is only one way to climb the top, that is 1, 0 to 1, right? So here we have n equals 2. We have already discussed this one, 1 plus 1 as well as 2, directly hopping into the second step. So right, so n equals 3, we have already discussed this one as well in the example basically, right? So either we can go with 1 plus 1 plus 1, path 1 comma 1 comma 1, and 1 step plus 2 step. So path is 1 comma 2, and 2 steps plus 1 step. So path is 2 comma 1. These are the 3 ways we have. So we need to return output as 3. So these are the 3 edge cases that we need to keep in mind. So now we are completely familiar with the edge cases as well as this one approach. We are good to write the code now. Let's start writing the. So the first step here is, if n is 1 or 2, then we can return n directly as the base case, right? So this is the base case. We have already discussed this one several times, right? If n is 1 or 2, we can return n directly. So I can just write in this way: if n less than or equal to 2, then what we will do, let's return n directly. This is fine, easy. So the next step, let's create the DP array of size n plus 1, right? So we will be creating the DP array of size n plus 1. Why we are creating this one? We have to store the solutions up to n, right, according to with the question. So that is the reason we'll be creating the array of DP array of size n. Basically, I'll go with the variable DP here. So this will be new int of n plus 1, DP array of size n plus 1. This is fine. So let's come to the first this one, base case basically. So there is only one way to climb 1, right? There is only one way to climb 1 step, and there are 2 ways to climb 2 steps. So let's mention this one. So here dp of 1 equals 1, and let me give here dp of 2 equals 2. So this is fine, easy. The next step here, we have to build the solution iteratively from 3 to n, right? So we have to check for all the so how we can give n as any numbers according to the constraint right here. So we have to build the solution iteratively for 3 to n. So let's make use of the simple for loop here. So here in this case, int, I'll just give, we are starting from 3, I less than or equal to n, as we are building the solution iteratively from 3 to n. It will be I equals 3, I less than or equal to n. Let's increment the I step by step. This is fine. So we'll be going with the recurrence. Recurrence, when I say recurrence, it will be f of n equals f of n minus 1 plus f of n minus 2. So this is almost similar to the Fibonacci basically, right? F of n equals f of n minus 1 plus f of n minus 2. So this one I can write this one in this way. dp of I equals dp of I minus 1 plus dp of I minus 2. This is similar to the Fibonacci, right? If you have solved the Fibonacci, you will be knowing the basic Fibonacci numbers. You should be knowing, right, by this time. So the next step, the final step here is we have to return the total distinct ways to climb the n steps. In our case, it is dp of n. So I'll just go with return dp of n, right? So n here, this one, and we are speaking of. So this is fine. So let me hit the run button. We are done with the code. So let me hit the run button. So what? Huh? Why we are having this error? So let me do one thing. So let me remove this bracket. So I think I have to remove this bracket. No need of this bracket basically, or I should have given the return statement after this bracket. So this is fine. So let me remove the braces instead. So let me hit the run button again. So here, yeah, now we can clearly see the sample test cases are getting passed. Means the code works absolutely correct in this case. Let's see whether this works for all the test cases. I have hit the submit button. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is dynamic programming. We know this one, right? Bottom up approach, right? Or the tabulation you can call bottom up, right? So we have went with the DP. So what would be the overall time complexity here? The overall time complexity would be big of n. So why it is big of n? Because we are looping once from 3 to n. Here you can clearly see the line number 11 I'm speaking of, right? So we are looping once from 3 to n. So overall time complexity would be quite obviously big of n in this case. So what would be space complexity here? The overall space complexity would be big of n as well. Why it is big of n? Because we are making use of the array which is of the size n plus 1. The line number 6 I'm speaking of, right? So we are making use of the array of size n plus 1 basically to store the subproblem results, right? So overall space complexity would be quite obviously big of n as well. So the time complexity and the space complexity for the code that we have written is big of n for this problem. I hope the complexities are clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.